Dear students, today trigonometric functions chapter 5 RD Sharma class 11 exercise 5.2 we are going to start. Question number first, find the values of other 5 trigonometric function in each of the following. One trigonometrical ratio's value is given, so we have to find out the remaining 5 trigonometrical ratios value. So first part, cot x is equal to 12 upon 5 and this acute angle x in quadrant third. This trigonometrical ratio cot x is defined for acute angle x and this x lies in third quadrant. You know, in third quadrant tan and its reciprocal cot are positive, other trigonometrical ratios are negative there. For finding the other trigonometrical ratios value, we can apply here two types of methods. One is by using the identities and second is by using the triangle. So any method we can apply. So I am solving this question by using triangle. So this cot x is equal to 12 upon 5 it is given. Basically cot x is or cot theta is cot x is equal to 12 upon 5 is equal to base upon perpendicular. We can take base upon perpendicular. This cot is positive in third quadrant, that is why this value is positive. So make one right angle triangle for acute angle x. Small triangle we can draw. Suppose this is one right angle triangle and this angle is x, which is acute angle. For this acute angle x and this 90 degree, this is base, this side is base and this is perpendicular. And side opposite to this 90 is hypo. So base upon perpendicular, so base is 12, this is 12 and perpendicular is 5. In right triangle, if two sides are given, so we can calculate the third side by using Pythagoras theorem. Pythagoras theorem is h square is equal to p square plus b square or b square plus p square. So this is base and this is perpendicular. 12 square 144, 5 square 25, 25 plus 144 169 and take the square root of 169, this is 13. So this hypotenuse side we can write 13. Now we have all the three sides of right angle triangle, so we can write the value of any trigonometrical ratio. And when we talk about this plus sign or minus sign, so we have to use this x lies in third quadrant. Which trigonometrical ratio are positive and which are negative in third quadrant, this thing we have to follow here. So the value therefore other 5 trigonometrical ratios are other 5 trigonometric ratios are. So first we can start from sin x. Sin x is equal to perpendicular upon hypo. So sin x is negative in third quadrant. In third quadrant, tan and cot are positive, other trigonometrical ratios are negative. So first of all, put minus sign here. Then write the value of perpendicular. Perpendicular is 5 and hypo is 13. So value of sin x is minus 5 upon 13. Similarly, cos x cos x is equal to base upon hypo. Now cos x is negative in third quadrant, so first of all put minus sign here. Now put the value of base and hypo. Base is 12 and hypo is 13. So 12 upon 13. So value of cos x is minus 12 upon 13. Cos then tan x is equal to perpendicular upon base. Tan x is positive in third quadrant, so plus sign. No need to put plus sign. It is already plus. Perpendicular upon base. So this is perpendicular 5 and base 12. So 5 upon 12. Tan x is equal to 5 upon 12. Then cot is already given. Then sec x is equal to hypo upon base. Sec x is negative in third quadrant, so put minus sign first. Now hypo upon base. Hypo is equal to 13 and base is equal to 12. So 13 upon 12. 13 upon 12. So value of sec x is minus 13 upon 12, and one more last trigonometrical ratio, and cosec x. Cosec x is equal to hypo upon perpendicular. So this cosec x is negative in third quadrant. So first of all put minus sign and write the value of hypo and perpendicular. Hypo is 13 and perpendicular 5. So 13 upon 5. 13 upon 5. So value of cosec x is minus 13 upon 5. In this way we can write the values of other 5 trigonometrical ratios by using the quadrant sign. Here it is very important that which trigonometrical ratios are positive, negative in third quadrant. Question number first, part second. Cos x is equal to minus 1 upon 2 and x in quadrant second. The value of cos x is given minus 1 upon 2 and this x in quadrant second. So cos x is equal to so cos x is equal to minus 1 upon 2. Basically this cos theta or cos x is the value of cos x in terms of sides of right angle triangle base upon hypo. This is base upon hypo. Here this minus sign indicating that this trigonometrical ratio cos x value minus 1 upon 2, and this minus sign indicates that x lies in quadrant second. This acute angle x lies in second quadrant, and in second quadrant cos is negative. That is why this value of cos x is given minus 1 upon 2. So make one right angle triangle. Suppose this is 90 degree and this acute angle is x. So for this acute angle x and this 90 degree, this side is base, this is perpendicular, and this is hypo. So base is equal to 1, hypo is equal to 2. So here hypo and base we have calculate this third side by using Pythagoras theorem. Hypo square 2 square 4, and this perpendicular square subtract from here. 4 square 2 square 4 minus 1 square 1, 4 minus 1 3. So p square is equal to 3, so p is equal to under root 3. This value is under root 3. Now we have all three sides of right angle triangle. We can write the values of other trigonometrical ratios by using the quadrant sign. In In second quadrant, sine and its reciprocal cosec are positive. Other trigonometrical ratios are negative there. So therefore, other 5 trigonometric ratios are, start from sine. Sin x is equal to, sin theta is equal to perpendicular upon hypo. First of all, sin x in second quadrant, x lies in second quadrant. Second quadrant, sin is positive, so take plus sign. Perpendicular root 3 and hypo 2. So root 3 upon 2. Root 3 upon 2. Sin then cos is given. Tan. Tan x is equal to perpendicular upon base. Tan x is negative in second quadrant. So put minus sign and perpendicular upon base, perpendicular root 3 and base 1. Root 3 upon 1. Or we can write minus root 3. In second quadrant, tan is negative, that is why this negative sign is coming. Tan then cot x is equal to base upon perpendicular. Again, cot x is negative in second quadrant, so put minus sign and base upon perpendicular. Base is 1 and perpendicular root 3. So 1 upon root 3. 1 upon root 3. So cot x is equal to minus 1 upon root 3. In second quadrant, cot is negative, that is why value is coming minus 1 upon root 3. Cot then sec x is equal to base upon, sec x is equal to hypo upon base. Hypo upon base. In second quadrant, sec x is negative, so put minus sign. Hypo upon base. Hypo is equal to 2 and base is equal to 1. 2 upon 1. 2 upon 1. So we can write minus 2 only. In second quadrant, sec x is negative, that is why this minus sign is coming. And one more trigonometrical ratio, cosec x. Cosec x is equal to hypo upon perpendicular. In second quadrant, cosec is positive, so plus sign we have to take. Hypo upon perpendicular, hypo is 2 and perpendicular root 3, so 2 upon root 3. 2 upon root 3. In this way, we can calculate the values of other trigonometrical, 5 other trigonometrical ratios values. Question number first, part third. Tan x is equal to 3 upon 4 and x in quadrant third. X lies in third quadrant. In third quadrant, tan is positive and its reciprocal cot is positive. Other trigonometrical ratios are negative there. So first, this tan x is equal to 3 upon 4. Basically, tan x is equal to perpendicular upon base. So make one right angle triangle and calculate the third side first. Suppose this is right angle triangle. This angle is 90 degree and this angle x. So for this acute angle x and 90, this is base. This is base, this is perpendicular and this is hypo. So perpendicular is equal to 3. This is 3. Base is equal to 4. Calculate third side by using Pythagoras theorem. H square is equal to p square plus b square. So 4 square 16 plus 3 square 9. 16 plus 9 25. Take a square root. This is 5. Now we have all three sides, so we can write the other 5 trigonometrical ratios values. Therefore, other 5 trigonometric ratios are. 10 is given. Start from sine. Sin x is equal to perpendicular upon hypo, which is equal to sin x is negative in third quadrant, so put minus sign, and perpendicular is perpendicular upon hypo, perpendicular 3 and hypo 5, so 3 upon 5. Minus 3 upon 5 is the value of sin x. Minus sign is coming because x lies in third quadrant. In third quadrant, sign is negative. Next trigonometrical ratio, cos x is equal to base upon hypo. In third quadrant, cos is negative, so put minus sign, and base upon hypo. Base is 4 and hypo is 5. 4 upon 5. So value of cos x is minus 4 upon 5. Minus sign is coming because x lies in third quadrant. In third quadrant, cos is negative. Cos, then tan value is given. Then take next ratio, cot x. Cot x is equal to base upon perpendicular. In third quadrant, cot x is positive, so plus sign. No need to put plus sign, it is already plus. Base upon perpendicular. Base is 4 and perpendicular is 3. 4 upon 3. So value of cot x is 4 upon 3. It is positive because cot x is positive in third quadrant. Cot, then sec x. Sec x is equal to hypo upon base, and sec x is negative in third quadrant, so put minus sign. Hypo upon base. Hypo is 5 and base is 4, so 5 upon 4. So value of sec x is minus 5 upon 4 because this sec is negative in third quadrant. And one more trigonometrical ratio, cosec x is equal to hypo upon perpendicular. Cosec x is negative in third quadrant, so put minus sign. Hypo upon perpendicular. Hypo is 5 and perpendicular 3, so 5 upon 3. So value of cosec x is minus 5 upon 3. In this way, we can write the values of other 5 trigonometrical ratios by giving the importance to the x lies in which quadrant. Question number first part, fourth. Last part, sin x is equal to 3 upon 5 and x in quadrant first. X lies in quadrant first. In quadrant first, all the trigonometrical ratios are positive. So sin x is given 3 upon 5. Sin x is equal to 3 upon 5, and basically sin x is perpendicular upon hypo. The value of sin x is given positive because in first quadrant all the trigonometrical ratios positive, so sin also will be positive there. Make one right angle triangle for calculating the third side. Suppose this is right angle triangle, this is 90-degree angle, and this is x. So for this acute angle x and this 90, this is base, this is perpendicular, and this is hypo. So perpendicular we can take 3 here, hypo 5. Now use Pythagoras theorem and calculate this base side. 5 square 25 minus 3 square 9. 25 minus 9 16. Square root of 16 is 4. So this side is 4. Now we have all the 3 sides of this right angle triangle. So we can write the values of other 5 trigonometrical ratios. Therefore, other 5 trigonometric ratios are sine value given, so start from cos x is equal to base upon hypo. In first quadrant, all trigonometrical ratios are positive, so plus sign. Cos base upon hypo, base is 4 and hypo is 5, so 4 upon 5, positive value. Cos then tan x is equal to perpendicular upon base. Tan is also positive in first quadrant, so perpendicular is 3 and base is 4, 3 upon 4. Tan then cot x is equal to base upon perpendicular. Cot is also positive in first quadrant. Base is 3 and base is 4 and perpendicular is 3. 4 upon 3. 4 upon 3. Now cot then sec x. Sec x is equal to hypo upon base, and sec is also positive in first quadrant. Hypo upon base, hypo is 5 and base is 4, so 5 upon 4 positive. And one more, cosec x is equal to hypo upon perpendicular. Cosec is also positive in first quadrant, so plus. H upon p, hypo is 5 and perpendicular is 3, so 5 upon 3. So these are the values of other 5 trigonometrical ratios. Question number second. If sin x is equal to 12 upon 13 and x lies in second quadrant, so find the value of sec x plus tan x. So one trigonometrical ratio sin x is given 12 upon 13 and x lies in second quadrant. In second quadrant, sin and its reciprocal cosec are positive. Other trigonometrical ratios are negative there. So we have to find out the value of sec x plus tan x. So for finding the value of sec x and tan x, first we will calculate the value of sec x and tan x. Then we can add them for sec x plus tan x. So sin x is equal to 12 upon 13 and x lies in second quadrant. Sin x is perpendicular upon hypo. So first calculate the third side by using first calculate the third side of triangle. So make one right angle triangle. Suppose this is right angle triangle. This is 90-degree angle and this angle is acute angle x. For this x and 90, this is base, this is perpendicular and this is hypo. So perpendicular is 12, hypo is 13. By using Pythagoras theorem, first calculate this third side. So 13 square 169 minus 12 square 144. 169 minus 144, 25 only. Take the square root of 25, 5. So this third side will be 5. Now we have all the three sides of right angle triangle. So first we can write the value of sec x and tan x, or directly we can use this. So I am calculating the value of this sec x. So sec x is equal to hypo upon base. In second quadrant, sec is given in second quadrant. X is given in second quadrant. In second quadrant, sec is negative. So take minus sign. Hypo is hypo upon base, hypo 13 and base 5. So 13 upon 5. The value of sec x is minus 13 upon 5 and the value of tan x. Tan x is equal to perpendicular upon base. Tan x is negative in second quadrant. In second quadrant, tan is negative, so put minus sign first. Perpendicular upon base, perpendicular 12 and base 5, 12 upon 5. So value of tan x is minus 12 upon 5. Now we have the value of sec x and tan x both. So directly we can calculate the value of sec x plus tan x. Therefore, sec x plus tan x is equal to, the value of sec x is minus 13 upon 5, minus 13 upon 5, plus the value of tan x is minus 12 upon 5. Simplify this, minus 13 upon 5 plus minus multiplication minus 12 upon 5. Take LCM, LCM 5. So this is minus 13 and minus 12. Minus 13 minus 12, minus 25 upon 5. We can cancel it. 5 5s are 25. So which is equal to minus 5. This is the required value of sec x plus tan x. Sec x plus tan x is equal to minus 5. Question number 3rd. If sin x is equal to 3 upon 5, tan y is equal to 1 upon 2, and x is greater than pi by 2 and less than pi, and y is greater than pi and less than 3 pi by 2, this condition is given. Find the value of 8 tan x minus root 5 sec y. So here two different angles are given, x and y, and for them conditions are also given. So with the help of this sin x, first we will calculate the value of tan x, and with the help of tan y we will calculate the value of sec y. After getting this two value, we can substitute here only. So one by one. Sin x is equal to 3 upon 5, it is given, and sin x is equal to perpendicular upon hypo. The value of x is given, x is greater than pi by 2 and less than pi. Greater than pi by 2 and less than pi means the value of x lies in second quadrant. In second quadrant, sin is positive, that is why the value of sin x is given positive 3 upon 5. So with the help of this 3 upon 5, this is perpendicular and this is hypo, calculate the third side. Make one right angle triangle, small right angle triangle. This is 90 degree and take this angle as x. For this x and 90, this is base, this is perpendicular and this is hypo. So perpendicular 3, hypo 5. Calculate this third side by using Pythagoras theorem. 5 square 25 minus this 3 square 9. 25 minus 9 16. Square root of 16 is 4. So with the help of this triangle, we can write the value of this tan x. So therefore tan x is equal to perpendicular upon base. In this second quadrant, x lies between pi by 2 to pi. In second quadrant, tan is negative. So first take negative side. Perpendicular upon base, perpendicular 3 and base 4. So minus 3 upon 4. The value of tan x minus 3 upon 4. Now, one more trigonometrical ratio, tan y is given. And tan y is equal to, it is given 1 upon 2. Tan y is perpendicular upon base and the value of y is given, y is greater than pi and less than 3 pi by 2. Greater than pi and less than 3 pi by 2. Means y lies in third quadrant, greater than 180 and less than 3 pi by 2 means 270. So y lies between 180 and 3 pi by 2, that is y lies in third quadrant. In third quadrant, tan is positive, that is why the value of tan y is given positive. Now, with the help of this two sides, perpendicular and base, make one right angle triangle and calculate third side. Suppose this is right angle triangle, this angle is 90 degree. Take this acute angle as y. For this y and 90, this is base, this is perpendicular, and this is hypo. So perpendicular is 1, base is 2. By using Pythagoras theorem, calculate this third side. 1 square 1 and 2 square 4. 4 plus 1 5. Square root of 5 is under root 5. So this third side is under root 5. Now we can write the other trigonometrical ratio values. Sec y is required. So therefore sec y. Therefore sec y for acute angle y. Sec y is hypo upon base. In this third quadrant, y lies in third quadrant. In third quadrant, sec y is negative. Tan and cot are positive there. Sec y is negative. So take minus sign first. This is minus. Hypo root 5 and base 2. So root 5 upon 2. Root 5 upon 2. So value of sec y is minus root 5 upon 2. Now we have both values tan x and sec y. So we can calculate the value of 8 tan x minus root 5 sec y. Now 8 tan x minus root 5 sec y. Root 5 sec y is equal to 8 into the value of tan x we calculated minus 3 upon 4 minus root 5 and put the value of sec y. The value of sec y is minus root 5 upon 2. Minus root 5 upon 2. Simplify this, which is 4 2s are 8 and 2 3s are minus 6. This minus minus plus root 5 into root 5 5 upon 2. Take LCM. LCM 2. 6 2 ja minus 12 plus 5. Minus 12 plus 5 minus 7 upon 2. This is the required value of 8 tan x minus root 5 sec y. Question number 4. If sin x plus cos x is equal to 0 and x lies in fourth quadrant, find sin x and cos x. Here one condition is given, sin x plus cos x is equal to 0 and x lies in fourth quadrant. So we have to find out the value of sin x and cos x. You know, in fourth quadrant, cos and its reciprocal sec are positive, other trigonometrical ratios are negative there. So first use this given condition, sin x plus cos x. Sin x plus cos x is equal to 0, or we can write this sin x is equal to, shift this cos x this side, minus cos x. By cross multiplying, sin x upon cos x is equal to minus 1. So sin x upon cos x is tan x is equal to minus 1. The value of tan x is coming minus 1. Reason is because x lies in fourth quadrant. In fourth quadrant, tan is negative. X lies in fourth quadrant. Fourth quadrant. X lies in fourth quadrant. So this tan x is equal to minus 1. We can take tan x is equal to this minus 1 upon 1, and tan x is basically perpendicular upon base. So make one right angle triangle and calculate the third side. Suppose this is right angle triangle. Suppose this is right angle triangle, this angle is 90 degree and this acute angle is x. For this x and 90, this is base and this is perpendicular, and side opposite to 90 is hypo. So perpendicular is 1, base is also 1. Calculate this third side. H square is equal to p square plus b square. So 1 square 1 and 1 square 1. 1 plus 1 2. Square root of 2 is under root 2. So this third side came under root 2. Now we can write the value of sin x and cos x. And x lies in fourth quadrant. Therefore, sin x is equal to perpendicular upon hypo. In fourth quadrant, sign is negative, so put minus sign. Perpendicular upon hypo, perpendicular is 1 and hypo is root 2. So this is 1 upon root 2. So value of sin x is minus 1 upon root 2, and cos x. Cos x is equal to base upon hypo. In fourth quadrant, cos x is positive, so plus sign. Base upon hypo. Base is 1 and hypo is root 2. 1 upon root 2. So these are the values of sin x and cos x. Sin x minus 1 upon root 2 and cos x 1 upon root 2. X lies in fourth quadrant, that is why sin is negative and cos x is positive. Question number 5. This is the last question for this exercise. If cos x is equal to minus 3 upon 5 and x is greater than pi and less than 3 pi by 2, find the values of other 5 trigonometric functions and hence evaluate cosec x plus cot x upon sec x minus tan x. First, we have to find out the values of other 5 trigonometrical ratios. One trigonometrical ratio cos x is equal to minus 3 upon 5 given, and this x lies between pi to 3 pi by 2, means x lies between 180 to 270 degree, that is this angle x lies in third quadrant. In third quadrant, cos is negative, that is why the value of cos x is given negative. So first we have to find out the values of other 5 trigonometrical ratios. After finding them, we can use that values for finding the value of cosec x plus cot x upon sec x minus tan x. So cos x is equal to minus 3 upon 5. Basically cos x is equal to base upon hypo. Make one right angle triangle. Suppose this is right angle triangle. This is 90 degree and this angle is x. So base is 3. For this acute angle x, this is base, this is perpendicular and this is hypo. So base is equal to 3, perpendicular is equal to 5. So we have to find out this hypo value first by using Pythagoras theorem. H square is equal to p square plus b square. So 5 square 25 and 3 square 9. 25 plus 9 34, and square root of 34 is under root 34. So value of this base is equal to 3 and hypo is equal to 5. So first find this third side by using Pythagoras theorem, and Pythagoras theorem is h square is equal to p square plus b square. So h square is 25 minus this 3 square 9, 25 minus 9 16, and square root of 16 is 4. So this perpendicular side is 4. Now we can write the values of other trigonometrical ratios. Therefore other 5 trigonometric ratios or functions, we can say trigonometric functions are start from sin x is equal to perpendicular upon hypo. Here this x is greater than pi and less than 3 pi by 2. Means this angle lies between 180 and 270 degree, that is in third quadrant. In third quadrant cos is negative. So sin x is equal to p upon h. In third quadrant sin is negative, so put negative sign first. Perpendicular is 4 and hypo is 5. So 4 upon 5. The value of sin x is minus 4 upon 5. Cos is given already. Then tan x is equal to perpendicular upon base. In third quadrant tan is positive, so plus sign. Perpendicular upon base, this is perpendicular and this is base, 4 upon 3. 4 upon 3. Then cot x is equal to base upon perpendicular. Cot x is also positive in third quadrant, so plus sign. Base upon perpendicular, base is 3 and perpendicular 4, 3 upon 4. Value of cot x is 3 upon 4 cot. Then sec x is equal to hypo upon base. In third quadrant sec is negative, so minus sign. Hypo upon base. Hypo is 5 and base is 3, so 5 upon 3. 5 upon 3. The value of sec x is minus 5 upon 3 and one more ratio, cosec x. Ratio or function is the same thing. Hypo upon perpendicular. Cosec x is negative in third quadrant, so minus sign. Hypo upon perpendicular. Hypo is 5 and perpendicular is 4, so 5 upon 4. 5 upon 4. Now we calculated the values of all 5 trigonometrical ratios. Now we have to use these values of trigonometrical functions for finding the value of cosec x plus cot x upon sec x minus tan x. So now cosec x plus cot x upon sec x minus tan x is equal to the value of cosec x is this minus 5 upon 4 plus the value of cot x is this cot x 3 upon 4. 3 upon 4. Sec x, the value of sec x is minus 5 upon 3. Minus 5 upon 3 minus tan x, the value of tan x is, this is tan x, this 4 upon 3. So minus 4 upon 3. Simplify this. Take LCM in numerator and denominator. Here 4 LCM, so minus 5 plus 3, and denominator 3 LCM minus 5 minus 4. Double fraction, so shift this 3 in numerator and this 4 in denominator, so which is equal to minus 5 plus 3 minus 2 into this 3 upon minus 5 minus 4 minus 9 into this 4. This negative cancelled. 2 2s are 4, 3 3s are 9. So in numerator 1 and 3 2s are 6. So this 1 upon 6 is the required value of cosec x plus cot x upon sec x minus tan x. So all the questions of this exercise 5.2 we have solved. The remaining questions for this chapter we will see in next class. Okay, bye.